All right, welcome back. We're continuing to talk about Chapter 10. We're on Section 10.1, doing the second part of the percent section. So in this next part, we're going to go a little more application-based, a little more reading problem to dig for the important information. It won't be quite as straightforward as the last video. All right, so I'd like you to look at I think we're on page 2 of your note packet, and you'll see where it says other types of percent problems, where a little more wordy to dig for the information. So a formula I like for you to use is to know the amount or the part, you might even call that the part of something that you're comparing. The part or the amount is the percentage. That's the obvious part in all of our word problems is the percents always have the word percent by it or a percent symbol. So that one's easier to dig out of the information. So the percent times the base, the original amount or the referenced amount or the total amount in some problems. So what could get confusing sometimes is which one's the amount and which one's the base. Now a lot of times, most of the times maybe, the amount is smaller than the base. We take a portion of the base. But like we saw in the last video, sometimes someone gets a 110% raise. It's like they were making $10 and now they're making $22. So they got more than 100% of a raise. So you can't always just go by that. You have to dig into the problem and see, what the amount and the base are. From the reading, you will find the amount is the part that they're referring to. Like if you went from making $10 an hour and now you make $22 an hour, the amount of the raise is $12. You got a $12 raise. That would be A. The amount of the raise, the percent. In this case, we would be looking for what percent raise is that. And then the base was what you used to make. You used to make $10 an hour. So let's use that as an example. If you get a $12 raise and you want to know what percent raise is that times the base, you used to make $10 an hour, we could call the whatever part's missing, this is where I'm going with this, we're going to use this kind of thought to do equations where they're missing one of the pieces of information. Now you can call this any letter that you want. I'm going to call it P for percent, but you can call it C for Cindy or S for Sarah, whatever. The variable letter does not matter. But this kind of clues us in. You've got an algebra problem. $12 is what percent of $10? $10. So to solve that, you divide by what's with your variable. Because that's times dividing, we'll undo that and do the same thing to this side. That gives us P equals 12 divided by 10. And so when you do 12 divided by 10, you can check that out. You get 1.2. And then as a percent, we've got to do the percent moving ourselves always in these equations. So we've got to move it 2 places. That's 120%. 120% is our answer. That person got 120% raise, we would say. Or you could say they're making 220% of what they used to make, if you could phrase it that way as well. But the raise is 120%. All right, so that's what we're going to do on this next little set. I've got some other examples here for you. You can think of this formula as the amount is the percent times the base, or A equals P times B. So if you can pull out which one's A and B, you can use this equation method instead. Sometimes it's not necessary to go this deep into it, but you might find some of the problems that we're getting into now, and you'll find in your homework you will need to do this. Now, if they're like the ones we did in the last video, just work them like I said there, but we're moving into a little more in depth. So, for example, it says 2 is 50% of 4. 2 is 50% of 4, if I write it just like it's written here. Notice that the 2 is the amount of the whole, 2 is the amount, and the base would be 4, and 50 is obviously the percent. I want you to notice that we could really write this as 2 is equals 50% would be changed to 0.50 or 0.5, of would be the times sign, and 4. So a little helpful hint on these, if it's written real straightforward like this, not too many wording or different arrangement, but it's very straightforward. When it says 2 is 50% of 4, it's written in A equals P times B form. You can simply change your is, which we've seen in other sections. Is oftentimes where the equal sign is, and the word of means times, oftentimes. So we can go by the of and is method and change is to equals, of to times, and then we can work it that way. In our problems we'll get to, they'll leave one of these pieces out and we'll have an equation to solve. Again, if we say 9 is 30% of 30, again we know 9 equals 0.3 times 30, and that is a true statement. If you multiply that, that is true. And then lastly, we've got 25 is 20% of 125. So again, written in the is and of form, where we can shortcut these. Let's say we didn't know some piece of that. They left out the 125, and we made that a variable. Again, variable of your choice. We could write that as 25 equals 0.20 of means times b. And then we would have an equation to solve, and we could revert back to our equation solving methods and say I'm dividing by, if something's times onto the variable, I divide by that amount to get b alone. Then do the same thing to this side, divide by 0.20 or 0.2, and then that should give you the 125. You can check that out and see that that is so. So the is and of method. So again, if you want to pause the video, number 13 through 15 will be like that and use this method. So please do always pause and practice these. It'll make your experience better before you come back in and see the answers. All right, so here I'll keep rolling with this. So to solve this problem, we got 52 is our equals. What percent? I'm going to call that the variable p. Of is times 26. So to solve this, I divide by the 26 on each side. It cancels that out. Type that on your calculator. You get just a regular 2 or 2.0. And that's not in percent form though, because I need to go to right before it's in percent. That kind of moving to right makes the percent sign appear is kind of how I say that. It's not in percent form until you've moved the decimal to right places. All right, so that's answer 13. Number 14, 25 is equals, 19% is 0.19 of what? So times b, so we divide by what's times to our variable, divide by 0.19, do the same thing to each side. That gives us b equals, do that on your calculator, let's see, and that gives me 75. Is that right? I don't know if I typed that in correctly. 25. I don't know why I second guessed that one. It just couldn't read my writing. Yeah, that is not correct. I knew something didn't feel right about number 14. 25. Yeah, I didn't type that one in right, did I? I don't think I did. Okay. Yeah, I wrote the problem wrong on my notes. Sorry about that. All right, so what should the correct answer be? You all probably know already. You're ahead of me here. 25 divided by 0.19. Anytime you see a mistake in any of my videos, please do send me an email so I can revise that, not be embarrassed. Like I just about had the wrong answer there. But it should be 131.6. Okay, then number 15, what? So that's our unknown variable is, that's my equal sign, 26% of 79. So what, and you can use any letter you want. I'm going to use A for amount. Is equals 0.26 times 79. That one I won't have to use my magic algebra skills because it's already on the same side. I just need to simplify what's on that same side. 0.26 times 79. So A equals 20.54 for that answer. All right, moving along. And then below that, I just kind of describe what I did here in some words in case you didn't hear the video. But then after that, it says, oftentimes, if it is a true reading problem, it's not just straightforward like that, although some of your homework problems will be just like that, but then you'll have a few that you have to dig a little deeper. The words are more scrambled up and more descriptive, so you have to search for the percent, the amount, and the base. But those are the three players in any percent problems. The amount, the part of the total, the percentage, that one's the obvious one with the percent sign, and then the base. What are they referring to as the larger picture? or the original amount, or the before amount, that base thing that we're referring to. So the referenced amount, maybe that's the way to say it. All right, so our example here, it says if the price of a jacket was reduced by 25% or $12.50, what was the original price of the jacket? So here we can reason out that $12.50 is the part or the amount of the whole. It's the amount that it was marked down by. So that's our A value. And then 25, like I said, is the obvious one with the percent sign. So what we're missing there is the base. So using our formula, and you may have developed strategies over the years that you just feel these and can work them out without the formula method, and that's just fine too. But this is a always work basic form to do any percent problem. So do bear with me on that. So $12.50 is an amount. The percent is given as 25%. We don't put percent signs in equations, so we have to go 2 left to get rid of the percent sign. And then we're missing the base reference amount. All right, so then it gives us an equation to solve. We divide by what's with our variable. So divide by 0.25 on both sides. And then base will be, divide that on your calculator, $12.50 divided by the, oh, I've got that one here in your notes somewhere. And that came out to be $50. So that was, and you shoppers out there that know a good deal on how to figure out your percents, you knew that a long time ago, right? You'd already figured that out. But this is also always holds true. This is the fallback method to use for any of these percent problems. All right, number 16, figuring out your tip. Okay, and again, you probably have developed strategies for that over the years too, but this also falls in line with this base idea of using amount is percent times base. The amount of your tip, that would be the part of the whole. The amount of your tip is the percentage tip, if you're 15%, 20%, whatever you're going by, times the base. And base would be your total, your total bill before you're putting your tip on. So in this one, the restaurant bill is $46.89. And we don't know what the tip is, so amount is unknown, we'll call it A. And we want to leave a 15% tip, which will be 0.15. Don't forget the little time sign there, you use a dot or an X. But this one I won't have to use my algebra skills, it's already on the same side, so punch that in your calculator, and you get about $7. So however you want to round that to the nearest penny, if you're going to leave your exact change, $7.03 there. Okay, then number 17, we got a $36 jacket is reduced by $10. So we're looking for the percent on this. So the amount of decrease, it's a $10 discount. The percent is unknown, and the base is that $36 jacket. This helps us to see to divide here. We did one like this earlier, so the earlier method, the amount divided by the total also works, but this is a more elaborate always works type of method for any problem. That comes out to be 27.8%. Okay, number 18. Number 18 is about our world population, and it asks you to figure out, oh wait a minute, no, this one's different. There's one later I was thinking of. Okay, number 18 again, if you have not already read these, please pause and do so. It gives the value for the India's population that is 15 years or younger, so a stat on that, and they said it's 31% of India's total population. So again, you might look at that number and think, that's a big number, it must be the base, but it is not. That is the amount of the population that's 15 years or younger. So that is just an amount, the A value or the part of this total. We've got the percent that's 31% of the entire population. So we're missing the big number, the entire population in this case, B, the reference value. So this formula tells us to divide by 0.31. When you do so, it cancels that out. This is what we do in our calculator, and you get 1,088,000,000 and so amount of people here for your answer there, for the base. Okay, then lastly, number 19, last on this video, we'll come back and do some more. Please do try to do them ahead. There's 57 new employees at King's Daughter. That would be an amount. They say that's 30%. So how many people work there before the new hire? So we're missing the base we'll divide by 0.30, so it's just the same in line, looking for the base by taking the new amount, or the part of the total divided by the percent. Divide that out, that means there was 190 employees before.